Hey, welcome back, my friends. I've had a lot of fun going over all these quads and stuff. I know we're moving quick, so I decided to go ahead and make a work-through video of one of today's assignments. This is the quads with trig puzzle piece. It's one of the ones that is a grade. It is due, but we're going to work through all of them right now. Some of the big assumptions going in is that you do know the properties. When I say congruent diagonals, you know that's isosceles, trapezoid, rectangle, and square. When I say diagonals bisect each other, you know that's all the parallelograms. You know, parallelogram, rectangle, rhombus, and square. You know what the tree looks like. I told you guys in class. This tree is basically the new SOHCAHTOA. You need to know it and use it often. You need to be able to draw it quickly. And it's like SOHCAHTOA for this. Like it has everything in it. You got to know the tree. Okay, so I'm going to work through these. I'm going to go quickly. You can, of course, pause, rewind, fast forward, and watch what you need to watch. The first question says that we have a parallelogram. It's called ABCD. So I'm going to draw a parallelogram called ABCD. Sounds pretty awesome, right? If I take this, I don't know, I don't know if Schoology makes good parallelograms, but here we go. And if it's called ABCD, it doesn't matter where I start, but you do have to go to consecutive corners. So you cannot crisscross the shape. You can go clockwise or counterclockwise. So either clockwise or counterclockwise when you name shapes. The diagonals intersect at E. So we have a parallelogram where the diagonals intersect at E. If AE is 3x minus 6, that's this part is 3x minus 6. Whoop. And AC, that's the whole thing, AC is 5x. Whoop. Find AC. So we know if it's a parallelogram that the diagonals bisect each other. So we know that this over here is also 3x minus 6. So two of those would be 6x minus 12, and that equals the whole thing, 5x. So x has to be 12. So if x equals 12, then AC is 12 times 5 is 60. And this would be 12 times 3 is 36 minus 6 is 30. So how long is AC? AC has to be 60. So diagonals bisect each other. We know that these have to be equal. So two of those, right? 2 times 3x minus 6 has to equal the whole thing, 5x. ABCD is a square where the diagonals intersect at E, so we got a square. Pretend that's a square. And it's called ABCD once again, A, B, C, D. The diagonals intersect at E. I have a feeling we're going to be drawing this picture a lot. AD is 6. Find the measure of angle ABD. Well, that's 45 degrees. We know it's a square, so we know it's 90. We also know that a square is a type of rhombus, so the diagonals cut the corners in half. So we know we have a bunch of 45s there. And the length of AC. So we know that this triangle is going to be a 45, 45, 90. So it's going to be 6, 6, 6 root 2 for that hypotenuse. Let's go. Squares are going to be 45, 45, 90s. Here we have a rhombus called PQRS. So we're going to have whoop and whoop, whoop. And it's not going to be perfect. Never mind. That's pretty good. So we got a rhombus called PQRS. PQRS. And they intersect at M. So I'm going to draw the diagonals. Ooh, the diagonals will tell us just how close we were. You think we got it? Oh, pretty good, actually. Dang. It's a rhombus, so we know that the diagonals are perpendicular. We know all 4 sides are equal. We know the corners are cut in half. We know so much. Let's see what we need to use. It says QRS is 8x. Wait a second. That's an M here. QRS is 8x. So if the whole corner is 8x, I'm going to put 4x in each part because we know in a rhombus that the corners are cut in half. QRP That's just this much, and they tell us that is 3x plus 8. So already I know that 3x plus 8 equals 4x. So x has to equal 8. So we know that already. X is 8. Because QRS is the whole corner, and QRP is half the corner. Boom. Okay. QS equals 20. It is a type of parallelogram, so if the whole thing's 20, we know it cuts into 10 and 10. If x equals 8, this is going to be 32 and 32. Okay. Find the following. The measure of angle MRQ. MRQ is going to be this angle here. MRQ, that's 32. PSR. PSR, that's this entire corner. There's a couple of ways to get this. I'm going to talk about both ways. The first way is we know that we have a right triangle. So this is a right triangle where you have a 32. So we know that 90 minus 32 is going to be 58. So you could know that half of it is 58. So PSR, the whole thing, is going to be 116. That's one way you could do it. The other way you could think about it is this entire corner is 64. And you know that consecutive corners of a shape have to add up to 180. So if this entire corner is 64, and here, just real quick, draw a blank rhombus. If this entire corner is 64, then this entire corner has to be 116. Because these consecutive corners have to add up to 180. That's a rule. Okay. Boop. I'm going to get rid of a lot of that mess that... I can do this. I can do this. There we go. All right. So we got that. PMQ. PMQ. Well, that's just a right angle. That's 90 degrees. And then QR. So this, it says round to the nearest thousandths. QR. They already used X in the problem, so I'm going to call it Y. And you can choose different corners or different sides, whatever. Like, I'm going to use this right triangle. And on that right triangle, I'm going to draw it off to the side here. What I have is 32 degrees. I have 10, and I have Y. So that's going to be a sine problem. I know that the sine of 32 equals opposite over adjacent. So if Y is down low, they switch places, you know. So it's going to equal 10 divided by the sine of 32. Well, I need to type that in. Make sure you're in degrees. And that's going to be round to the nearest thousand. It's going to be 18.871. So there are your four answers. So we got another rhombus. Oh, okay. Let me just do this. No. Got it. I'm going to clean you up, make you look all nice and shiny and new. There we go. Look at this beautiful rhombus. Now let's copy you. You're coming with me. That way I don't have to draw it again. I don't know what takes longer, but here we go. I got a rhombus. Is it the same name? Oh, it's G-H-I-J. Okay. Okay. So G-H-I-J, and it intersects at K. All right. If GH is x squared, that means they're all x squared because a rhombus, all four sides are equal. And HI equals 5x plus 36. Well, we know those are equal. So we know that x squared equals 5x plus 36. They both represent a side. And we know that all four sides of a rhombus are equal. So we have GH. Let me make sure I got that right. GH and HI. Yeah, they're just going to be equal to each other. So this is a quadratic. You need to make one side 0. So we're going to subtract 5x. We're going to subtract 36. And then what factors of 36 subtract to equal 5? It's going to be 9 and 4. I want the answer to be negative 5. So it's going to be minus 9 plus 4. So x equals 9 and negative 4. Now let's plug them in. If I plug in negative 4, let's try that negative. That's one people don't like. What is negative 4 squared? 16. What is negative 4 times 5? Be negative 20 plus 36, also 16. That's okay. 16 is fine. So it could be 16. How about 9? 9 squared, 81. 9 times 5 is 45 plus 36, also 81. So it's one of those, 16 or 81. Find the length of IJ. Well, that's the same size again. So it's going to be 16 or 81. It's got to be one of those. Nice. We have an isosceles trapezoid. Let's go. Oops. Okay. All right. We'll pretend that's isosceles. An isosceles trapezoid, so these two sides are equal, where the diagonals intersect at E. Remember, an isosceles trapezoid, the diagonals are equal for the first time. We're saying they intersect at E. It's the diagonals. It says BC is parallel to AD. So I got to name it where that works out. It's called ABCD. So if I go ABCD, that does not get this done. Right now I have AB and CD parallel, so it can't be like that. What about if I go like this? ABCD. If I go that way, and that checks out. Now I have now I have BC is parallel to AD. So I got that. If AC equals 12, then what is BD? Well, those are the diagonals. We know the diagonals are the same size, so they're going to both be 12. If the mid segment is 18 and AD equals 12, I'm going to get this out of my way. The mid segment would go here, and they're telling us that the mid segment is 18 and AD is 12. Find BC. I'm going to call it X. So remember the rule that the average of the bases, so 12 plus X divided by 2, the average of the bases equals the mid segment. So 12 plus X would equal 36, right? If I multiply 2 to both sides, the 2's cancel out. I get 36. And then X would equal 24. So how long is BC? It's going to be 24. Boom. Okay. So here we have a parallelogram. Something like that. I don't know. Looks close enough to me. It's called PQDR. Diagonals intersect at M. PM is 2x plus 7. So that means this is 2x plus 7 because on a parallelogram, the diagonals bisect each other. MD is 4y minus 1. So I know that 2x plus 7 equals 4y minus 1. Because those are both representing the same thing. RM is 4x minus 5. So that means this is 4x minus 5. And MQ is 3y plus 4. So we also know that 4x minus 5 equals 3y plus 4. Systems time. Guys, there's a few ways you can do this. And I'm going to do it a slightly longer way just because it's the way that I think most people need to be solving this. When you're solving systems that are not real easy substitutions, and this is not an easy substitution, you want to get them in the format of AX plus BY equals C. That's the best strategy for most people. If you can do it a different way faster, that's okay. I don't care, as long as you execute it correctly. But a lot of people can't. So I'm going to show you this strategy. So the first equation, I have 2x. I'm going to subtract the 4y over. So the 4y is gone, the 2x is gone, and then I need to move the 7 to the other side. And that would give me negative 8. So that's the first equation. I have 2x, stayed in the same side. I moved the 4y over, had to be minus 4y. And then I moved this 7 to the other side, giving me negative 8. So there's what I have for my first equation. Second equation, same idea. I have 4x, right, stays the same. Move the 3y over, minus 3y, equals, move the 5 to the other side, equals 9. We talked about this in class, but we can multiply an equation by any number we want. Well, right now the x's are both positive, the y's are both negative. I want one positive, one negative, and I want them to be the same number. The easiest way to pull that off that I can see is to multiply the first row by negative 2. And that'll give me negative 4x plus 8y equals positive 16. And there, what happens when you have 4 and negative 4? They kill each other. They're dead. They're gone. It's a fight to the death and no one won. And then I have 5y and 25, so y equals 5. Once I know y equals 5, I can go back up here, and it doesn't matter. I'll pick this equation. I plug in 5 for y, and you'd have 2x. 4 times 5 would be 20. So add 20, you'd get 2x equals 12, x equals 6. And if you want, plug it into the other equation too. If I plug in 6, I get 24. If I plug in 5, I get minus 5 times 3 would be 15. Is 24 minus 15, does that equal 9? Yeah, so I pretty much know I got the right answer now. So x equals 6 and y equals 5. So how long is PD? Well, plug in 6 for x, that would be 12 plus 7, be 19. 19 times 2, PD's the whole thing, would be 38. How about RQ? Plug in 6, that'd be 24 minus 5. That would be 19. 24 minus 5 is 19, so that is also 38. Huh. Is it a rectangle? We know it's a parallelogram, they told us. But aren't these diagonals congruent? Aren't they both 38? So yes. When do you have congruent diagonals? Let's look at the tree real quick. Did we make it earlier? Where did we make that? Oh, here we go. Here are my shapes with congruent diagonals, and here are my parallelograms. So is that a rectangle? Yes, a rectangle is the first shape that has both properties. ABCD is a rhombus. Hey, check it out. I got a rhombus right there. Boom! Let me erase those letters because they're not the same. All right, ABCD is a rhombus. A, B, C, and to the D. Intersect at E. All right, given ABD is 36, so this would be 36. So that means this is 36, this is 36, this is 36, because that's 90. 90 minus 36, that's going to be 54, 54, 54, 54. Let's go. Rhombuses are folded in half both ways. The opposite sides are equal. The opposite angles are cut in half. Like, we just got lots of symmetry here. AB equals 16. That means all the sides are 16. Find the following. Angle AEB, 90 degrees, that's perpendicular. Angle BCD, the entire corner BCD would be 108. EDC, 36.
Like, can you help us with the problem?
AE, I'm recording a video. You come back like in 5 minutes.
Okay.
We got AE here. Well, that's going to involve this right triangle. Boop. So I'm going to draw that right triangle. I got 16. I got 36. Let me write that a little better. And I need, what do I need? AE, I need this side. I'm not going to call, I'll call it X, it's fine. So that would be the sine of 36 equals x over 16. X is up high. All you got to do is multiply. So it'd be 16 sine 36. It says round to the nearest thousandths. That'd be 9.405. So AE would be 9.405. And then what does BC equal? Well, that's also 16. Good question. I like that question. All right. Oh, sorry. We got ABCD is a kite. It says AB equals BC. So I'm going to do ABCD so that AB equals BC. That means AD equals DC. Okay. The diagonals intersect at Q. So it's going to look something like this. Q. We know it's a right angle. All right. So it says ADC is 60 degrees. This entire corner is 60. Because it's a kite, you have a line of symmetry. I know that this is my line of symmetry on this problem. That means it folds left over right. So if this entire corner is 60, it's going to cut into 30 and 30. DQ is 12, and check it out. 30, 60, 90, let's go. So this would be the 60. So let's do sidebar. 60, we have a 12, so it's going to be 12 divided by root 3, which is 12 root 3 over 3, which is 4 root 3. Let's get it. This is going to be 8 root 3. You got to know your 30, 60, 90 rules. Do not use sine, cosine, or tangent. So this would be 4 root 3, and this would be 8 root 3. This would be 4 root 3. This would be 8 root 3. They're all reflected. What is DC? Oh, that's the question. 8 root 3. Let's go. 8 root 3. ABCD is a rectangle. Get rectangles. Okay. A, B, C into the D. It says BC is 5, so this is 5. CD is 12, so this is 12. If the diagonals intersect at M, okay, let's look at this. They want angle ACD. Okay, so diagonals intersect at M. Find the measure of ACD to the nearest thousandths. I'll call this X. So I don't know if you can see it. I hope you can see it. This is a right triangle that we can work on. This is X, this is 5, this is 12. If you want to know the angle, that's inverse trig. This is going to be opposite over adjacent. This is going to be the inverse tangent of 5 over 12. So they said find the measure of angle ACD. That's it then. Inverse tangent of 5 over 12. Round to the nearest thousandth. That's 22.6198 would round to 620. Beautiful. Beautiful. Quantitative comparisons. All right. So basically we want to know, is it greater than, less than, equal, or not enough information? When you have quantitative comparisons, those are your 4 choices. So the number of sides of a parallelogram, 4. The number of sides of a rectangle, 4. The 2 quantities are equal. On this one, if this is a 4-sided shape, we know that it's going to be 360 minus 110 minus 90 minus 75. I'm going to type that in. 360 minus 110 minus 90 minus 75. This corner is 85. So X and 75. Well, that's 85 and 75. 85 is bigger than 75. So quantity in column A is bigger. Note, the figure is not drawn to scale. In parallelogram QRST, the measure of angle QRS, this corner, is less than the measure of angle RST, this corner. Okay. So this is the big, wait, QRS is the smaller corner. So if this is the smaller corner, then this is the smaller diagonal. The wider the corner, the wider or longer the diagonal. So QS has to be smaller than RT. The smaller corner has the smaller opening. If they're telling us that this is the bigger corner, then purple is the bigger diagonal. RT is the bigger diagonal. So column B, quantity in column B is always greater. It's only because of this. If you take this line away, there's no way to know, and we would say not enough information. So if this is the picture, we don't have much. Like it looks like what it does, but it might, we can't tell, but it might not be equal. Like we know these are parallel because this is 90 and 90, which means these two lines are parallel. I know that A plus B must be 180, but we have no way of knowing how big they are. So A and B, the relationship cannot be determined. They might be 90. We don't know. They look 90, but we cannot guarantee they're 90. It could even be like 90.01 and 89.99. We don't know. Find the value of x in the following. It says PQ is equal to QS. Oh. So those two are equal. And QR. Oh. Now, I have a 70 there. So because it's a kite, this is also 70. That means this entire corner is 70. Why? Because that's an isosceles triangle. That's an isosceles triangle. Those base angles have to be equal. That means over here, this is also 70. So what do we have here? 360 minus 140 minus 70 minus 70. So this corner has to be 80, which would make it 40 and 40. So that means that this is 50 and 50, right? Because we know it's 90 here. I'm going really fast. Let's slow it down. Whoa, sorry. We got a right triangle here. So I did 360 minus 70 this corner, minus 70 this corner, minus 140 this corner. And I got 80. And I know it's a kite, so that 80 became 40 and 40. And because this is a right triangle, if that's 40, this has to be 50. And if that's 50 and the whole thing's 70, those have to be 20s. Okay, I don't know what the question is. I'm just filling stuff out. Find the value of x in the following. Well, we just did that. It's 50. So x equals 50. That's a hard question. Oh, that's the end. Super fun. There you go, guys. Thank you for working so hard.